Okay, we're ready to finish up section 6.1 on trig inverses. What's going to happen in this section, and why I wanted to make it a separate video, is it's not just doing a trig inverse, it's really doing two operations. It wants you to evaluate the trig function and the trig inverse at the same time. So I'm going to do 3 examples out of your notes, A, C, and E. If you read this expression, it is asking you to do the sine of the sine inverse of a half. So it's asking you 2 things, 2 operations. It's asking you to get me the sine value of what's here, and then inside it's asking you to give me the sine inverse value of what's here. Well, just like in math, we always do what's inside the parentheses first. So if we start in the inside, this is a trig inverse. And a trig inverse means I'm giving you a number, you give me an angle. Because this number is positive, we know our angle is going to be in quadrant 1. So the question here is, what angle measurement gives you a sine value of a half? And by now we should know you cannot get a half off the unit circle. So it's got to be off our triangles. And the triangles we're going to look at are the ones with the 30 degree, because the side opposite is 1, the 30, or we can look at the 60 degree. Okay? So the question is, what angle measurement gives us a sine value of a half? What does sine mean? From the beginning of the semester, y over r. So if I put my finger on 60 and I do y over r, I do not get a half. If I put my finger on 30 and do y over r, I get out a half. So I now know this part of the expression I now know is 30 degrees. And we did exactly what it asked. Inverse means I give you a number, you give me the angle. But we're not done. Now this says I want you to do the sine of what's inside, which you just found out is 30 degrees. And that shows you I'm doing a trig expression, which means now I'm giving the angle, I want the number. Okay? So this is a 2-step process. So I'm giving you the angle 30 degrees and I want the number, and we know sine is y over r, and that number it would spit out is a half. So when I ask you to do the sine of the sine inverse of a half, that's the final answer, a half. Now, some of you are pretty quick. Some of you are going, hey, wait a minute, did I really need to do all that work? No, because if you're smart and you're making the connection about this word inverse, inverses are opposite operations. And what do opposite operations do to each other? What happens in math when we add 5 and subtract 5? We multiply by 3 and then we divide by 3. We square and then we square root. Opposite operations cancel out. So if you're quick and you realize sine and sine inverse are opposites, they are canceling out and they're leaving you with 1/2. Okay, but I did want to show you that that expression is really 2 operations. Okay, let's look at C. I want to do the tangent arc cosine of 3/4. So I have 2 operations here. I want you to find the tangent value of what's in here. What's in here is I want you to find the angle measurement that matches the cosine for 3/4. Okay, so arc means inverse, inverse means give me an angle. We always do what's in parentheses first. Now I know what somebody's thinking. Isn't the answer just 3/4? Don't we just cancel these out? No, they're not inverses of each other. Sine and sine inverse are opposites. Tangent and arc cosine are not opposites. The opposite of tangent would be tangent inverse. The opposite of cosine would be cosine inverse. So these are not opposites, they're not canceling it out. So we're going to have to work it both steps. So we start inside. I want an angle. How many degrees would the angle have to be to give me 3/4? Well, first of all, we know that this is positive, so we know what quadrant are we in. Very good. We're in quadrant 1. We know that. The angle measurement you're giving me is in quadrant 1. Can we look up the cosine of 3/4 on the unit circle? No. Can we look up the cosine value 3/4 on the 30 or on the 60? No, there is no 4. Can we look up the cosine value 3/4 on the 45, 45, 90? Well, if I draw my 45, 45, 90, that's 1, 1 in square root of 2. So you're right. There is no way for you to look up the cosine value 3/4 x over r on any of our references. So you're going to say to me, well, Miss Black, I can't find this angle without a calculator. And I'm going to say, you're right on that. You can't find the actual angle measurement, but you have enough information to do the tangent of that angle. Because this relates back to everything in Chapter 5. If you don't have enough information to find the actual angle measurement, and I will not let you use a calculator, trig is always a relationship between an acute angle and two sides of a right triangle. You at least, I expect you to know, well, this triangle's in quadrant 1. Let's draw it. And I'll call that angle, I don't know, theta. And I know the cosine is x over r. And all I need to do is find the missing side now. And I know how to find the missing side, Pythagorean Theorem, a squared plus b squared equals c squared. But we write it as x squared plus y squared equals r squared. Is that a triplet? Because I remember in our triplets there was a 3, 4, 5. It's not, because 4 can't be the hypotenuse. If you do the triplet 3, 4, 5, the 5 has got to be the hypotenuse. So the only way to find this missing side is to do our Pythagorean. X squared plus y squared equals r squared. X is 3. I don't know y. I know r is 4. 3 squared is 9. 4 squared is 16. I'll subtract 9. I'll get 7. I'll square root 7. I'll get plus or minus the square root of 7. It can't be both. Because we're in quadrant 1, we know that is going to be a positive value. So look at me. I agree with you. If arc means give me the angle, there is no way for us to come up with the actual angle measurement in degrees or radians with 3/4. We would need a calculator to get that angle. We're not allowed a calculator. It's okay. Whatever this angle is, which we're calling theta, we have a picture drawn. We can use that picture now to find the tangent of theta. Because if I put my finger on theta and I do my definition of tangent, which is y over x, I get square root of 7 over 3. And that's my answer. Now, it should make sense that your answer is a number and not an angle, because you did 2 steps here. The inside said find an angle, and then tangent says I have an angle, give me a number. Okay? But again, even though I couldn't find the actual degree measure of theta, I have a picture to get the tangent value off of. And because we're in quadrant 1, we know that number's got to be positive. Okay? Let's try the last example, E. I want to do the cosine of tangent inverse a -2. All right, we have 2 steps. I want to do the cosine of whatever's in here. What's in here is a tangent inverse, so I need to find an angle. First thing I'm noticing about what's in here is this number is negative. And if that number's negative, is my angle going to be in quadrant 1? No. So according to the principal of values, if we're doing tangent, if the angle's not in quadrant 1, what quadrant is the angle in then? Well, for tangent inverse, your angle is going to be between -90 and +90. So 0 to 90 would be quadrant 1. So 0 to -90 would be quadrant 4. So because this is negative, I know my triangle is in quadrant 4 because that's where my angle is. Now, again, can we use the unit circle to get a tangent value of 2? No. The only way to get, there's no way on the unit circle to get anything but 1, 0s, or -1s. Can we use our triangles to get a tangent value of 2? Well, let's go to our triangle. Put my finger on 30. Tangent is y over x. If I do y over x, I get 1 over square root of 3. That's not a 2. Put my finger on 60. If I do tangent, y over x, that's square root of 3 over 1. That's not a 2. If I put my finger on 45 and I do y over x, that's 1 over 1. That's not a value of 2. So you are correct. We cannot physically find the actual angle measurement in here. I have no idea how many degrees it is. I know it's not 30. I know it's not 60. I know it's not 45. And I know it's not off the unit circle. All we can do to keep working this expression is to draw what? A right triangle. So we will draw a right triangle in what quadrant now? Very good. 4, because our tangent value is negative. We don't know this angle. We're going to call it theta. To represent the sides, we know our definition. Tangent is y over x. So this is -2 over 1. So our y value is -2, our x value is 1. Let's find the radius. This is not a triple, so we have to do Pythagorean Theorem. X squared plus y squared equals r squared. 1 squared plus -2 squared equals r squared. 1 plus 4 equals r squared. 5 equals r squared. R is the square root of 5, and the radius is always positive. Okay? Now, I know what you're saying. Well, that doesn't help me. I still don't know this angle. I can't use my calculator. That's fine. Whatever this angle is, we're going to call it theta. We have a picture now to find the cosine of theta. Because to find the cosine, I put my finger on theta, and cosine is x over r. And x over r, the cosine of theta would be 1 over square root of 5, which we would simplify to be square root of 5 over 5, and we know in quadrant 4, cosine should be a positive number. So that makes sense. So there's our last part about trig inverses. Okay, if you can't find the actual angle without a calculator because it's not off our references, then you have to draw a right triangle. Now, we get to the fun part. 6.2, 6.3, and 6.4 are all about how we use inverses to solve equations. See you in the next video.